In this video, I'd like to look at converting a decimal number that is less than 1 to a floating point number, give it its floating point representation. So I'm going to start with this number, negative 0.00. How many O's? 1, 2, 3, 4, 5 O's, and then 987. Okay. So let's just take the first thing, the sign. It's a negative number, so the sign bit is 1. So that's the easy part. Okay, so now I'm done with the sign. I don't have to think about sign. So I'm going to take the fraction, and I'm going to, in scientific mode in my calculator, paste that in. Control V there, okay. And I'm going to multiply it. I'm going to start with 24 bits. I'm going to see if I were representing this if I had like 24 bits to represent the fraction and sort of like a fixed point, sort of an idea, what would it be? So I'm going to multiply that, my fraction, times 2 raised to the 24. I'm getting just 165 plus more, but I'm just going to start with the 165. I'm just going to truncate. Take my 165, go over to programmer mode in decimal, paste that in, and I'm using, here's my answer in binary, and I'm using just 8 of my bits. Control V. So it was, if I were writing it out, again, it was, I'm going to show more steps. Here, I multiplied that, Control V times 2 raised to the 24, and that gave me 165 point, I'll just say XXX, and that then converted to this, and it used 8 bits. And I was expecting 24, so I am missing 16 bits. And that means that the number at this stage is sort of 0.1234, 1234, 1234, 1234, and then 10100101. That's what we sort of have at this stage. We were that 16 missing numbers are zeros, so it's dot and then 16. So this means that this would be 2 to the minus 1, 2 to the minus 2. So here's my question. Is this number less than 2 to the minus 16? So let's go back to scientific mode and just see, does this make sense? 2 raised to the 16 minus is 0.1234, 4 zeros and a 1, and I have 1, 2, 3, 4, 5 zeros and a 9. So yes, I am less than that. So it makes sense for there to be these 16 zeros after the dot. Okay, so I want to do some shifting, but then I want 16 bits on this side, which I don't have. So I'm going to go back and repeat my process, but do it 16 more than the 24 in order to get those 16 additional bits out of it. So I'm still in scientific mode. I'm pasting in my fraction. Now, I missed my dot. Copy, clear, paste in my fraction, and I'm going to multiply that by 2 raised to the, I'll say parenthesis, the original 24 plus the missing 16, close the parenthesis, and equal. So now I get this number. Okay. And I'm not going to round, I'm just going to truncate. So now I'm taking this number. So now I'm down here, and I did this, and I'm going to convert that, but I'm doing this now. Showing my steps, 24 plus the missing 16 gave me this after, okay. I'm just going to truncate it. And then I'm going to convert it. Okay, so let me just copy what I want, go over to programmer, paste that in, and then here's my binary. Two things we should note. One is that it contains 1, 2, 3, 4, 5, 6 digit groupings of 4, which is the desired. So 1, 2, 3, 4, 5, 6. That is 6 times 4, 24. That's what I wanted, 24 bits at this stage. And the original 8 should be reproduced at the beginning. Okay. So that's going to be my mantissa without this 1. When it comes time to store my mantissa, I'm not going to store that leading 1. And now I want to figure out my exponent. So I'm going to take what I had originally, where those 16 zeros were in the front, and what did I just do? I don't know. So I had, try it one more time, copy, something weird going on in that cell. There it is. Okay. And now what do I want to do? I want to shift this until that dot gets to be in front. So in floating point numbers, like scientific notation, the dot is supposed to be after the first non-zero digit. The only non-zero digit in binary is 1. So I need to move that dot. To move it here would be move it 16 places, but I have to move it 17. So I have to move this to get that dot there now. And all those just leading zeros, which are meaningless, I have to multiply that by, let's say, x times 2 raised to the minus 17. So I'm moving the dot in a way that makes the number bigger, so I have to multiply it by a negative power of 2 to compensate, and that number is minus 17. And then I have to bias. So I have to bias by adding. So minus 17 with a bias of 127. And that's going to give me what, 110, right? Let's just confirm 127 minus 17 is the 110. And that's what I want to represent in binary. Okay, so that will be the exponent. So I have the mantissa, and I'm not going to store that 1. I'll make it red. I don't store the leading 1. And here's my exponent. So let's put the pieces together. My exponent is 0, 1, 1, 0, 1, 1, 1, 0. And my mantissa, I'm going to copy this, put it down a little farther on the page up here, and then fill it in my box. I'm not going to store the red one, the first one, 0, 1, 0, then 0, 1, 0, 1, then 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 0, 1, and then 0, 0, 1, 1. Okay, so this presumably is my representation. I'm going to squeeze that up. I'm going to bring in the floating point calculator, this online floating point calculator for comparison. Let's see how I do. So my sign bit, it was negative, so sign bit is 1. The exponent was 0, 1, 1, 0, 1, 1, 1, 0. Okay. Then my mantissa was 0, 1, 0, 0, 1, 0, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 0, 1. Now I lost it. 0, 0, 1, 0, 0, 1, 0, 1, 1. And there it was 0, 1, 1. That was an O. Everybody's off by 1 now. There we go. 0, 1, 0, 0, 1, 0, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 0, 1, 0, 0, 1, 1. Fine. Okay, there we go. And so they have its minus, which I knew, and 9.86 times 10e in computer world is times 10 to the minus. So this is times 10 to the minus 6. So if I took my number down here, 0.0000005 O's and 987, and put it into normal scientific notation, I would move that dot 6 places to 5 zeros and 1 more. And so it would be 9.87 times 10 to the minus 7, or sorry, 10 to the minus, I move it 6 places to get it in front of, after the 9. 1, 2, 3, 4, 5, 6. So that is negative 9.87 times 10 to the minus 6. And here it is in the calculator, minus 9.86999. So, close, makes sense. It matches. And that's what I wanted to show you. Thanks for your attention.